Hi students, in this video we're going to look at perfect squares. Alright, so after watching this video you should be able to expand perfect squares and also recall the rules that we can use to make expanding perfect squares a bit easier. Now the biggest thing to recall is how to expand binomial expressions. We did that in the previous lesson. But also perfect squares are just anything that can be evenly squared. So 6 squared is a perfect square, x squared is a perfect square. Even 3y minus 2 squared, they're all perfect squares because they're all squared. That's all there is to it. That's what a perfect square is. Now, let's consider the following binomial expansions. What we're going to do is expand these out and see if we can find some sort of pattern in terms of how we get, or between what we start with and what we finish with in our expanded form. So x plus 3 squared is the same as x plus 3 times x plus 3. All right, and then using our rainbows, we'll have x times x, which is x squared, x times positive 3, which is plus 3x, 3 times x, which is plus 3x, then 3 times positive 3, which is 9. In the middle here, we've got two terms that are like, so that can simplify down to x squared plus 6x plus 9. Can you see any pattern between the numbers that we've got here, the 6 and the 9, and what we started with? Maybe not yet, we'll keep going. X plus 5 squared, so x plus 5 times x plus 5, that's the same thing as x plus 5 squared. Expanding that out again, we'll have x squared plus 5x, and we'll have 5 times x and 5 times 5. So 5 times x is 5x, positive 5 times positive 5 is 25. Once again, we've got these two terms in the middle that are the same. X squared plus 10x plus 25. All right, so you might be able to start seeing a bit of a pattern here. So this back number here, this 9, well, that number is just 3 squared. This 25 here is 5 squared. And because in our expansion we do 5 times 5, get 25, and 3 times 3 to get 9. It's just 3 squared and 5 squared. Now this 6 in the middle though, well, that came from the fact that we have one lot of 3x there and one lot of 3x there. So really, in this term here, we have two 3x terms, one 3x term here and a second 3x term here. In our second example, we've actually got exactly the same thing. We've got two 5x terms here, one here and one here. And then together, that makes our 10x term, 2 times 5x. Those two 5x terms that we get from our expansion together make 10x. So we're starting to see a bit of a pattern here. This number in the middle, 6, is just 2 times 3. This number here on the end is 3 squared. In fact, this middle term here, it's 2 times 3, and then there's also an x there, which probably came from the first term. And same for the 2x times 5 down there. Let's look at this negative term. X minus 3 times x minus 3. Again, doing our rainbows. X times x, and x times negative 3. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 gives us positive 9. Collecting those like terms, x squared minus 6x plus 9. Notice how similar it is to the first example we did. This back term is 9. It's still 3 squared. This middle term is still 6 because you've got these two 3 terms in the middle. But this negative sign, that's new. That comes from the fact there's a negative in between here. So notice the back term is always positive, but that middle term, in this case, it's a negative because in our starting term, in our factorized term, we're subtracting, and in our first term, we added. So it was positive 6x. And using these sorts of rules, we can come up with some patterns that help us expand these. Without doing the full expanding, we can have some rules that help us do this in a way that's a bit faster. So perfect squares can be expanded using the following rules. For a plus b, the first term is just a squared. In the previous examples, we just used x, right? So a squared, b squared is on the end, and then in the middle, we have this 2 times AB section. So that's where we had, in our previous examples, we had 3x plus 3x, which was 2 times 3 times x, or we had 5x plus 5x, 2 times 5 times x, and so on. It's double these two terms multiplied together. Whatever a and b are, we times them together in the middle, then times it by 2. The rule is exactly the same for a minus b, except that instead of being a plus in between our first two terms, it changes to a minus. Notice that there is still a plus sign in between both, regardless of if it's a minus b or a plus b. That b squared term is always positive. It's just this middle term that changes from plus to minus depending on the sign in the middle. All right, so let's use this rule. And we want to expand x minus 5 all squared. So using our pattern, we square the first term. That's x squared. Okay, 5, we're going to square that. That is 25. What we're really doing there, students, is saying negative 5 squared actually equals positive 25. That's why it's always positive, that back term. And the middle term, it will be negative. It'll be negative because we've got a minus sign there. It'll be negative 2 times by 5 times by x. So that'll be x squared minus 10x plus 25. Going back to our previous example, we had x plus 5. That ended up being x squared plus 10x plus 25. Once we change that plus to a minus, the only thing that changes is that middle term, remember. So x squared minus 10x this time, because we've got a minus sign there. And plus 25 on the end, because that's 5 squared, and that's the same number as negative 5 squared. All right, let's do this last term. We've got 3x minus 2 squared. So again, using our pattern, we're going to do 3x squared minus 2 times 3x times 2. Once again, we have a minus there, so we have a minus here. And then plus, really it's negative 2 squared. So expanding that out, 3 squared is 9. And x squared is x squared. Okay, negative 2 times 3 times 2. Negative 2 times 3 is 6, times 2 again is negative 12x. Negative 2 squared is positive 4. And there's our expansion. All right, so after watching this video, you should be able to expand perfect squares, then recall the rules for expanding perfect squares.